feed, will it reduce it or increase? Increasing feed will reduce BUE or increase it, right? So increasing feed, I think, once you increase the speed of the tool, the BUE is going to be increased, right? So this is not a correct option. Another one, increasing depth of cut. Again, the depth of cut. For first pass, let's say you're giving too much of depth of cut. Obviously, there has to be some kind of welding in there. Okay? Yeah, that's what it is. And decreasing rake angle. Again, if you come back here, if we decrease the rake angle, all right? So will it reduce or increase the built-up edge? That's what is the question here, right? Okay, so Ankit says that increase cutting speed. Yes, if you are going to increase the cutting speed, so built-up edge is going to be reduced. All right, because there won't be any time for a partial welding. Okay, this is not welding in a very literal sense. All right, this is, I have written welding here in order to explain it to you. Okay, that's what it is. Yeah, Jagan Kumar, a very good evening. All right, yes, so D is the correct option for this. I hope that I have given you context. All right, hello guys. Yes, so Ankit, you are right. Jayant, you were right. Okay. Is that good? Chalo, next one. Increasing cutting speed, right? Okay, I hope that I have given you the context. And Ankit, yes, you're right, okay? Yes. And so what do you think about this principal cutting edge angle is? The third one. Can you please tell me this is a tool signature that has been given to you in ASA system? Right? So what do you think should be the answer? Yeah, Ankit, very correct. Good. I appreciate that. Okay, chalo. Come on. What do you think about this next question? Okay, Raviteja says it has to be. Okay, fine, good. Avinash, good to see you, Avinash, all right. Jagan Kumar also says it's okay, Vikas Kumar says it's okay, fine. I'm not going to reveal answers by this, okay. So Avinash, Raviteja, I think you're right, okay. Yes, Ankit, so does your experience tell about this? What is your experience telling about this, okay? So what is principal cutting edge angle? What is that? That is 90 degree minus side cutting edge angle, right? Side cutting edge angle. And what is side cutting edge angle? I'm going to, this one, right? This one is the side cutting edge angle. If you minus this by 90, all right, you're going to get principal cutting edge angle. So how much is the side cutting edge angle in here, right? So I have written down the formula. Now, how much is the side cutting edge angle? Yes, exactly. So Raviteja, you are right, exactly. So how much is the side cutting edge angle here? Can you please tell me? Can you please type in there? How much should be the side cutting edge angle? This is the ASA system, right? So you know how it goes, right? Back rake, side rake, right? So you know how does it go, right? Back rake, side rake angle, then comes end clearance angle, then comes side relief angle, this one, then comes end cutting edge angle, sorry for that, then comes side cutting edge angle, right? So what is the value of side cutting edge angle? That is the question, right? So here, this one gives you the side cutting edge angle, so this becomes nothing but 90 degree minus 12 degrees, so that is nothing but 78 degrees. All right, and let's see who does it very correctly. All right, yes, Love Avashti, it's good that side cutting edge angle is 12. All right, okay, nice, good. The next question. Okay, this is the portion of tool on which cutting edge is formed is known as. So can you please try to do this? Okay, I'm not going to tell you the diagram again. So can you please try to solve this? Yes, Ankit, you're right. It has to be 12. Side cutting edge angle would be 12 degrees. Okay, but the answer would be 90 minus 12 degrees, so 78, all right? Okay. So what do you think it is? Can you please try to answer this? You know, you can expect these questions, guys, all right? Nose. Portion of the tool on which cutting edge is formed is known as. Okay. So what do you think it is? Ankit says it has to be dash dash. I'm not going to tell what he said, okay? Jagan Kumar, again, BS, ES, no. So I'm going to just tell you this, okay? So can you please tell me this? So this is shank. Okay, this thing is shank over here. This is also shank over there, all right? This is face over here. Okay? And what's the next option? That is flank, right? This is the flank over here. This one is the flank. So what do you think it is? Now tell me, please, okay? And obviously this is the nose, okay? From here to here, the curved part is the nose, all right? So what do you think it is? Now, read the question very carefully, all right? So Deepak Agarwal says it's A. Jagan Kumar says rake face. So what's the answer, Jagan Kumar? That is what we want to know. Okay, so cutting edge is formed. Again, I'm going to tell you, okay, this one, there are two cutting edges, right? So this is primary cutting edge, all right? So this one is formed. Obviously, it's not nose. Nose is a part of, you know, that cutting edge, right? No, we cannot say that it's a part. But obviously, nose is not making up cutting edge, right? So it has to be face. This face is comprising of this cutting edge and that cutting edge. That's what is being asked, all right? So it has to be face. Are you getting that? There are two cutting edges, number 1 and number 2. This is called side cutting edge and this is called end cutting edge. Are you getting that? So what is asked is the portion of the tool on which cutting edge is formed. So this is, where is this being formed and where is this being formed? It's formed in the face, right? So face has to be the answer, right? Okay. Is that good? Yeah, a very confusing question, but a good question, all right? So face has to be the answer of this. Okay, Ankit Jaiswal, yeah, it's good to admit, all right? So yes, let's keep moving. The next one. Thoriated tungsten is preferred over simple tungsten electrode because it. So can you please tell me this? Now this one is a fact-based question, all right, because no one in the world knows what is thoriated tungsten, right? So this is, again, if you know it, it's good, and if you don't know it, it's also, you know, you can assume things here. Okay, so what do you think? What do you think it is? Okay, it's well also very obvious, right? The option that, okay, Ankit, I want you to hit one answer, all right? Obviously, it's written that it's preferred, so it's good, right? So don't worry, because everything is not given to you. Just, you know, assume things because it's already given that it's preferred. And when can it be preferred? Ankit, I'm talking to you, right? Out of these. Right? Everything is written in the question. So please, yes, make a tukka, all right? Make a tukka. So Abhishek Singh, it is preferred because it increases the risk of weld contamination. Okay, Ankit, so option D, because you are saying, you know, this is a bit misleading, okay? So Jagan Kumar says it's C. Increase the risk of, is it a good thing? Now please tell me, okay, is it a good thing? Is it a good thing? Decreases arc stability. Is it good thing or bad thing? Just tell me, okay? I am going to tell you how do you approach a question. Is it a good thing or a bad thing? Number 1. तुक्के मारने के लिए जरा सा दिमाग होना चाहिए, right? You should have, you know, something, you know. Is it a good thing or a bad thing? Just type in there, guys. Good or bad? Number 1. Avinash, what is the meaning of no? Is it good or bad? Just type good or bad. Exactly. So Abhishek Singh, I appreciate that. You have written that it's a bad thing, right? We don't want this. We want more stability, right? So we don't want this. Right? Yeah, Avinash, it's a bad thing. Is B a good thing or a bad thing? Is B a good thing or a bad thing? Yeah, exactly. Muthu, you are right. Okay. So 1 is bad. Then the next one, improves current carrying capacity, right? So more the current carrying capacity, more is going to be what? The penetration, right? And quicker is going to be, yes, exactly. So is it good? Yes, it is. It is good. Okay. We want this, right? Isn't it? What about C? Increases the risk of weld contamination. Is it good or bad? Yes, good. Now you are getting this, all right? How do we approach a question here? Okay, don't worry that, yes, Ankit Jaiswal, you're right. So option B is good. So what is C? Do we want this? Is it good or bad? Come on. Increases the risk of weld contamination. We want less contamination or more contamination, right? That's the question. Hello. So we don't want this, right? Increases the risk of weld contamination. We want minimum contamination, right? Yeah, exactly. So what should be the option? Obviously, D is not going to be the option, right? So what should be it? Obviously, all of the above cannot be there because we have written that thoriated tungsten is preferred. Now, what is the option? Can you please tell me now? Jagan Kumar, Buttu Kumar, Ankit Jaiswal. Yeah, exactly, Ankit. Now you are getting this, okay? Don't worry if you know this or don't know this, okay? So, in this way, you can always answer something, all right? Yes, exactly. Anish, you are right. We don't want more. Increases the risk of weld contamination. We don't want that, right? So which option should be the correct one? Option B. Yes, good guys. Okay, so B is the option. All right. So that's how you approach, any question. All right. This is what I can tell you. My job is to tell you the approach. Okay. Yes, exactly. So Jagan Kumar, you're right. So we don't want this, right? Risk of weld contamination. We don't want to increase that, right? So this is how you approach something, all right, guys? Okay, chalo, the next one. Hello. Is it good? Yes. Is it good? Come on, chalo, the next one. Arc blow occurs in. Okay, Ankit, that's fine. It's better if you go to the app and do it there because you can find so many value additions in the app, all right? So if you can go to the app and watch this, Ankit, I'm talking to you, okay? So arc blow occurs in. Come on. Rohit Kumar Sharma. Okay. शर्मा जी भी आ गए चलो good okay Abhishek Sona Rohit so what do you think it is arc welding Jagan Kumar arc welding all right so yes now I'm going to ask you why arc welding okay maybe you're right why arc welding okay this is very important guys okay this you need to understand otherwise without understanding, it's going to be really... Yes, A is the option. Chalo. I give it to you, okay? Ankit, Avinash, Abhishek, and Tushar, okay? Jagan Kumar, I give it to you. You are correct, all right? But why arc welding alone? Can you just think about it? Can you please just think about it? Okay, I give it to you because you know that there's a problem with arc welding, right? So what happens is, Okay, so let's say this is the arc. Okay, this is the shortest distance. This is the shortest distance of arc, right? Isn't it? Yes? Yeah. So Sona, you're right. I'm really happy that you understand it. Okay, good. Yes, Sona. Okay, this is how it should be. Okay, shortest distance of arc. This is how it should be, but somehow it goes something like this. Okay, it deflects. The arc deflects. Now, okay, this is how it is. This is nothing but arc blow, right? Okay, this is how it is. Okay, so what can be the reason of this deflection? Can you please tell me? Yes, exactly. Yeah, Jagan Kumar, you are approximately right. Okay, why this deflection might happen? Can you please tell me? Sona, yes, you are partially right. All right. So can you please tell me why this deflection might happen? Arc is what? What is arc? That is nothing but flow of electrons, right? So I'm going to take you back. Okay. So Chandan, okay, fine. So arc deflects obviously because of a force, right? Because, okay, so I'm going to just write this happens just because of force. Obviously, right? If someone pushes you, you're going to get deflected, right? So anything gets deflected by an external force. Yes. So here what is happening is this is just nothing but a magnetic force. A magnetic force that is being acted on this arc, all right? Because arc is nothing but movement of electrons, and when electrons move, okay, they create their own magnetic field, all right? And because of the interaction of magnetic field, there's a force. Yes, exactly. So it is because of magnetic force, all right? That's why it happens in arc welding alone. Lectures. Ankit Jaiswal, you don't get notifications? Oh. So can you please do one thing, Ankit? Okay, I suggest one thing. Just, can you please uninstall it and install it again? So because even I also get notifications, all right, Ankit Jaiswal. Okay, fine. So the next one. In metal casting, skim bob is used for which of the following purposes? Can you please try this? Come on, guys. Can you please do this? Yeah, so Ankit, I have already replied to you, okay? That's what it is. Jagan Kumar, it's the best answer, okay? That's what it is. It's the best answer, arc welding, because I have already told you that when an electron moves, let's say, when an electron is moving, it creates, when electron moves, it creates a magnetic field. All right, so that's why it's happening in arc welding. All right, that's what it is. Jagan Kumar, sometimes you just need to find out the best answer in there. All right, that's what it is. Okay, so scab is a defect of sand casting, machining, welding, and forging. Now this is yeah. Chalo. Sashank, okay. People are saying welding. Okay, fine. Higher. Strainer. Oh, sorry, I just missed that, right? Yeah, this one. Okay, fine. So what do you think it is? Come on, guys. Tushar C, Anish B, A, removing heavier impurities, removing lighter impurities. Yeah, it is just, skim bob is nothing but something that we use to collect impurities, all right? Yes. So it doesn't matter if it's lighter impurities or heavier impurities, just for collecting the impurities. So I'm going to say that it's both A and B, all right? Okay, is that good? So it has to be C according to me, all right? But yes, you can always challenge that, okay? You can always go back and read it. Is it good? Don't believe in anyone. Even if God tells you and you don't believe, yes, you have the right to say no, no, all right? So this is a democratic way that I like, okay? Chalo. Okay, so it has to be A and B according to me. So it doesn't matter if it's heavier impurities or lighter impurities. It is just used for both of them. Okay? Chalo, the next one. Scab is a defect of now this one. I thought you were talking about welding in here, right? Chalo. Chalo. So what do you think it is? Scab is a defect of sand casting, machining, welding or forging. What do you think it is? Gyan Prakash. Okay. So what do you think it is? Avinash. AA. Okay, fine. It'll be sand casting. Rohit. Yes. Okay, fine. So scab is obviously a defect of sand casting where a very fine layer of the metal or alloy protrudes outside the casting surface that we call scab, all right? Yes, so every one of you got it correctly, all right? It's really good, okay? Chalo. Which of the following flux coating materials act as an arc stabilizer? Now this is entirely fact based, okay? Now, yeah, act as an arc stabilizer because you need to go into what can I say? Into the structure or microstructure of these to answer this. Okay, so what do you think it is? What do you think it is? Arc stabilizer. Yeah, so Murli and Dilingesh, okay. I hope that I pronounced that name correctly, alright, don't take it otherwise. And okay, so what do you think it is? Neeraj Chaudhary says it's ferrosilicon, sand casting. Murli says it's A. Avinash also says it's A. Okay, and according to us, it's also A, okay? Potassium silicate is an arc stabilizer. Again, we are talking about, arc stability is nothing but minimizing the arc blow or arc deviation. That's how we say, an arc is stable, right? And other material can be potassium oxide or sodium oxide. Potassium, yes, silicate or potassium oxide can also be used in this, okay? So A is the answer here, and this just needs a cramming, all right? That's what it is. Okay, now this one. What is the main feature of non-conventional machining over conventional or traditional machining operation? So which one of these is correct in terms of unconventional machining? That's the question, guys, okay? So can you please try to answer this? Chalo, let's do this. Let's do this. Sona, as I told you, okay, Sona, as I told you, you need to just cram this. Sometimes we just need to cram something, all right? Because you need to go inside the potassium silicate microstructure to understand, okay, which one of these is stabilizing an arc, all right? That's how it goes. And most of these things are established through experiments. Okay, so sometimes, yes, we need to accept some things, all right, at least in production. So this is what I can tell you, all right, Sona? Okay, so what do you think it is? Okay, JP Adda, Anish, Dilingesh, Anish. Rohit Kumar, you just cannot prepare for such type of question, okay, so don't worry about it. No one can prepare for a fact-based question. It just depends on, sometimes it depends on the luck. So yes, harder work can be machined with softer tool materials. That's how unconventional processes of machining operations are. Tool wear is high. Is it correct? No, it's not correct. Tool and workpiece must be in contact. That's also not correct because they can be in a distance, right? And machining is very slow. No, that is also not true. So yes, it has to be D. Harder work can be machined with softer tool material, right? Unlike the conventional machining part where the tool has to be harder than the workpiece. All right. Chalo, yes, Avinash, good, well done. The mechanism of material removal in ECM process is A, B, C or D. Now this is very straightforward. This is how it is, right? Chalo. The mechanism of material removal in ECM process is, come on guys, chalo, let's do this. You know, ready. Yeah, this I think everyone should get it correctly, alright guys. So now, okay. ECM, electrochemical machining. Come on guys. So it's a chemical, you know, something related to chemistry, right? Chemicals. So what should it be? Yes, yes. There was a series, right, in which that person used to dissolve everything, right? Breaking Bad, I think. Breaking Bad, yes. Right, so what it would be? It's chemistry over here. So what should it be? Melting and evaporation? Is anything melting there and evaporating? I don't think that, right? So it has to be ionic dissolution, yes. Even the name is sufficient, right? Electrochemical machining, right? Yes, so ionic dissolution. Is it good? Now ionic is just corresponding to chemistry, right? So this is how you make it up. Even if you don't know the answer, this ionic is a chemistry term, right? You find ion, ionic bond, covalent bond and all, right? So that's why it has to be A, ionic dissolution. Come on guys, good, well done. Okay, so the next one. In which of the following milling operations cutter is rotated against the direction of travel of workpiece? Yes, Sona, it's good that you came back, okay? Yes, chalo, let's do this. Okay, Varun Singh, Gyan Prakash, Aman, JP Adda, yeah, Aman, Ankit. So what do you think it is? Yeah, JP Adda, I have come up with the next question, all right. Yes, and there's just one you know, not suggestion, I won't say suggestion, okay, there's just one request to share this video so that it reaches maximum people and so that they can also be benefited, guys, okay. And whatever we give, it comes back to us, right? Newton said it so years back, okay. So I'm going to tell you this. Now tell me, okay, this is up milling and this is down milling. So which one should be the answer, right? I think yes, almost every one of you got it correctly, right? It has to be up milling because this is the direction of workpiece and this is rotating, the cutter is rotating in this direction, opposite to the workpiece or the velocity of the workpiece, right? So it has to be A. Yes? Okay? Okay, Ankit, yeah. So, you know, Ankit, so let me answer to you, okay? So, for example, this one, you know, people can take this one as a fact-based question, all right? But because I have shown you this, so you have connected to it enormously, right? Instantly, so that you remember it, all right? That's why I'm sharing these images with you as well. I think there was just one fact-based question, this one, right? This one is entirely fact-based question. Okay, others, I tried to explain them to you logically, all right? So that, you know, you can understand them and you can go ahead. Okay, Ankit Jaswal, good. So that is up milling, okay? Against the direction of travel, so it has to be up milling according to this, all right? Okay, now this one. So what do you think it is? Yeah, Diligesh, I'm really, because a query came up, all right, so. So what do you think it is? Sorry for that. Looks like I have been screaming a lot. Okay. So, what is brine? People are saying that brine, what is brine? Can you please tell me what is brine? What is this? Because we know air, we know oil, we know water, but what is brine? Let's talk about that. Yes, Prakash, you're right, okay? So, what is brine? Yes, exactly. So this is nothing but concentrated salt in water. Or I should write it more precisely like this: concentrated salt and water. So what has been found is brine gives more, fastest rate of cooling in quenching, okay? Yes, thank you, Dilangesh. Corona, yes. Because I've been coughing, that's why, you're trying that, okay? Yes, maybe that's why, the doubt is coming up, okay? Yes. Yeah, thank you, Dilangesh, okay? So that's what it is, and that's how it is. Brine, actually, what it does is, it gives you the fastest cooling rate of steel in quenching, right? Okay, chalo, the next one. Again, that has to be a bit remembered, all right? Chalo. In the TTT diagram of heat treatment for carbon steel, vertical axis represents temperature on linear scale, and horizontal axis represents time on logarithmic scale. Yes, Jagan Kumar, I agree to you. Corona is everywhere, okay? But we need to act right. We need to work right. That's how it has to be. Chalo. So what do you think it is? Come on, guys. Chalo. What do you think it is? So, what do you think it is? Come on, guys. Vertical axis represents time, temperature, transformation, that is, okay? TTT, time, temperature, transformation. Temperature, time, transformation, it can also be called that. No, no hard and fast rule to cram everything. Okay, temperature on linear scale and also time also on linear scale, okay? More answers? Come on, I'm looking for more answers about this. Can you please think about more answers? Actually, it is, A, okay? Vertical axis, this is nothing but T, temperature, this is nothing but log of T. Okay, T, T, T. So, can you please think about why this is log of T, log of time? Log of time. Why are we taking log of time? Like, that has to be the question, okay? So, log of time. Can you please think about it? Why? Yes, Neeraj, you're right. You're right, it has to be A, okay? Neeraj, you're right, Neeraj Chaudhary. Okay, so fine, so why log of time, right? Can anyone think about this? then we are going to disperse, all right? So can anyone think about this? Why are we talking about log of time, right? So just think about it, okay? We'll talk about it tomorrow again. And just go back and think about it. Why log of time? Why not log of temperature, right? That has to be the question, okay? Chalo, the next one. Addition of magnesium to cast iron increases its... Again, now it looks like a very fact-based question, okay? But yeah, this is how it has to be, okay, guys? Okay? No, Gyan, it's not that. It's time that is, log of time that is being taken in incorrectly, all right? So what do you think it is? Shaktivel says it's going to be B, okay. Yogesh says it's going to be C, okay. Jagan Kumar says it's going to be B, and okay, so any more answers? Yes, exactly. So, it's nothing but ductility and strength in tension, okay. That's how it is. Now if we add magnesium to cast iron, there's something called spheroidal cast iron or spheroidal graphite cast iron. It's kind of that, okay. So yeah, it's B actually. So it improves, it works on ductility, and yes, it improves the strength in tension as well. Okay. Is it good? But still, yes, cast iron is not ductile, but still, what it does, it changes the microstructure, works on the microstructure, and and the result that we get is something called spheroidal, okay? Keval. Spheroidal cast iron, something like that. Is it good? Hello, is it good? Now again, this is, this needs a cramming, okay? This needs a cramming. Chalo. Obviously, it won't make it as ductile as a mild steel, right? Don't compare it with a mild steel or a chewing gum, right? It cannot happen like that. But yes, because cast iron is extremely brittle, it works or reduces the brittleness, making it a bit ductile. That's how it is. Yeah, so what do you think it is? Now again, it's a tukka question, right? You just know this, and then only it can be done, right? So what if a similar question comes up in the paper? That's why we are doing this, okay? So, low alloy, high alloy, low alloy, high strength, low alloy steel, and medium alloy, high strength steel, okay. For example, we say low carbon steel, right? So let me give you a hint kind of thing. For example, plain carbon steel is written over here. So what is low alloy steel? Let's say we say that low carbon steel, right? So that's why Jagan Kumar, okay, I'm going to give you some insight, okay, some trick in this. So we say that, okay, low alloy steel. Now what is the meaning of low carbon steel, right? Low carbon steel means that the constitution of carbon is going to be very low, right? That is what is the meaning of low here, isn't it? And high strength, medium alloy. Again, this one is what? The composition is going to be medium. That's how it is. Right? Yes, exactly, Keval. So, low carbon steel means that less carbon content. And here also, you just need to figure out if these elements are added in low quantity or a medium quantity. or it can be plain carbon steel. Okay, plain carbon steel, I don't think it's an answer, right? Plain carbon, how can it be plain carbon steel? Copper, vanadium, nickel and molybdenum, right? Yes, exactly. So Jagan Kumar, what do you think it is? So, should they add it in medium quantity or in low alloy, low quantity? That's what is the question, right? Because this is gone out of question, plain carbon steel. No, it cannot be plain carbon steel. Come on guys, I'm just giving you an insight how to approach this problem. So which one? So the question is, Ramesh Mon, question is, do you add them in low quantity or do you add them in medium quantity? Right? If you can figure that out, you can answer this. That's the question, okay, Rajdeep Singh. So people are saying that, okay, it has to be C, maybe, medium is the average, but it's going to be B, okay, high strength, low alloy steel. Okay, I've given you context on what means low and what means medium and what means high, all right. So that's what it is, okay. Yeah, so best option obviously would be, to go with medium because that's an average, right? Whenever we are confused, we take the average. Okay, so yes, that's what it is, okay. So it has to be high strength, low alloy steel. But see, Ankit, I have tried to give this fact-based question a logical face as well. Okay, that's how I have, made it understandable to you. And that's how you should be preparing, okay? Because you cannot cram all of these things. You cannot remember all of these things, okay? That's what it is. Okay, so go back, Ankit, just go back and just, try to find it out if they are added in medium quantities, large quantities or small quantities, okay. So that will be your answer, okay. So that's what it is, and I like to give some insights here so that you open your mind. Otherwise cramming is not going to help you, okay. Hello, so I'm done here guys. So we have some green cards like this, and you can use them for our test series and all. Okay, and I'll see you tomorrow again, preferably the same time, okay. As it's good to see you again, Ankit, Raviteja, Ramesh, Jagan, okay, and Dilingesh. Just tune it to us tomorrow as well, and I suggest that, or I request to you, it's a humble request to share this video with others so that others can be benefited as well. Okay, and thank you very much. I think that I had given you something to think about, right? Because production is not just about remembering things, right? I tried to present everything in a very logical way, whatever I could, okay? I gave my best. So I'll see you tomorrow. Till then, be happy, keep on smiling, keep on dreaming big, okay? Because as Sachin Tendulkar told us, dreams do come true, okay? So keep on believing in your dreams and look forward. And have a very good mental attitude. Till then, a very bye, and take good care of yourself. Be blessed by the divine. Thank you.